Welcome back. So today we're looking at successive approximations. All right, now let's look at our EQ and that'll make more sense. How can you find solution or solutions to a system of a linear and a quadratic equation? Okay, so we're going to be comparing two different types now. So it says analyze the following graph and table to find the solutions of the system. Okay, so if we're given a graph, if I want to know what the solutions are, well, what solution or solutions do they share? So if I look at this graph, I'm looking for the points that they share. So up here, where do the graphs, because one's linear, one's a parabola, so where do the functions intersect? 4, 5. That is one of my solutions. Now look and see where the other one is. Right down here at 0, negative 3. So 0, negative 3, and 4, 5. So looking at a graph, it's pretty clear to see. Unless they are not nice points. Like they're not nice where the x and y's are intersecting. So we'll learn how to do that as well. Now what if we're given a table? Now when I look at this table, the first things I notice are I have some blanks here. I have some things missing. So I'm going to look at my f of x function first, and I want to fill in those missing pieces. So I want to know what's f of x when x is 2. All right, well I'm just going to plug it in. So f of 2 equals, so 2 squared minus 2 times 2 minus 3. So I have 4, and then negative 2 times 2 is 4. So 4 minus 4 is 0 minus 3 gives me negative 3. Okay, so let's do it again. F of 4. So I've got 4 squared minus 2 times 4 minus 3. So 16 minus 8 is 8. 8 minus 3 gives me 5. All right. So now I want to complete my g of x. So g of 0, oh that's nice. So g of 0 equals 2 times 0 minus 3, so 0 minus 3, negative 3. And now 3, g of 3. So g of 3 equals 2 times 3 minus 3, so 6 minus 3 gives me 3. Beautiful. Okay, so I'm going to look at this table and I want to kind of figure out, well, what am I comparing? So I'm comparing f of x, which is a quadratic function, to g of x. Fill in your invisible ones. So I am comparing another quadratic to a linear. So if I want to know what solutions they share, I'm just going to see, are there any points that they have in common? Negative 1, 0, negative 1, negative 5. Nope. 0, negative 3, 0, negative 3. Oh, sweet. So that is a solution that they have in common. Okay, so 1, negative 4, nope. 2, negative 3, 2, nope. 3, 0, nope. 3, 3, doesn't work. 4, 5, yes. 4, 5. Okay, so this table displays what this graph was. So we have it graphically and now displayed as a table. So as a table, you are looking at the points that they share, that they have in common. And graphically, you're just looking for where do the functions intersect. All right? Now, what if something is not a nice solution? Now, successive approximation is a method. However, I'm not going to teach you that way. Because successive approximation is setting up a table, and it's a lot of guess and check. Like to the nearest, so it's when it's not nice, so it's to the nearest tenth. So you'd be plugging in things like 4.1, 4.2, 4.3, etc. to both functions a lot of times to figure that out. Well, why would we do that when we know how to solve a quadratic? So, solving algebraically. So again, here I have a quadratic, and I have something linear, and I want to know, do they have any solutions? So to find that out, basically we're using substitution, all right? We're going to plug this one in here, and we're going to see what makes them equal to each other, if they do. So I've got negative 6x plus 16 equals 2x squared minus 6. Okay, so first I need to establish what am I solving? Well, I've got quadratics involved, so I know when I'm solving quadratics, I need a set equal to 0. That way I can try and either factor, use the quadratic formula, completing the square, so on. So it's a quadratic. Let's go ahead and get that set equal to 0. So I'm going to add 6x to both sides. And I'm going to go ahead and subtract 16 while I'm at it. So 0 equals 2x squared. That's my only x squared, so that'll start us off. And then I have a positive 6x, no other x's. And then we have a negative 6 and a negative 16. So that gives me negative 22. All right, beautiful. So now I have a nice quadratic. So I'm going to go ahead and factor out my 2. And I'm left with x squared plus 3x minus 11. Alrighty, I want to look at this and I want to see, is this factorable? So I'm going to do the jingle. A times C. So factors of negative 11 that give me a positive 3. 11 is prime, so 1 and 11 are my only factors. Not happening. Alright, so I'm going to go ahead and B is not going to be nice for completing the square because it's an odd number. So I'm going to end up with some nasty fractions. That's me. So I'm going to go ahead and use the quadratic formula. Shall I sing to you? I know you love it. All right, so opposite of B. No, just kidding. But we are going to do that. So opposite of B. So negative 3 plus or minus square root. All right, what's B squared? So again, positive 3 squared gives us 9 minus 4ac. All right, what's A? A is 1, so 4 times 1 times C, negative 11, all over, don't you forget all over, 2a, and again, A was just a 1. So 2 times 1. So negative 3 plus or minus the square root of 9, and I have negative 4 times 1 is negative 4 times negative 11, positive 44. So 9 plus 44 all over 2. So negative 3 plus or minus the square root of 44, that's going to give me 53. Divided by 2, 53. I cannot simplify that radical. 3 is not divisible by 2 anyway, so that is simplest form. So our solutions, oh wait a minute, we can't stop there because we need a solution. These are just our x values. Alright, we're going to have to break out the calculator so that we can plug this back in easier. So x equals, alright, in your calculator, actually let me try and bring up the little calculator so you can see what I'm plugging in. Alright, so I've got negative 3 plus the square root of 53 equals, or don't forget to hit your equal sign, divided by 2, so 2.14. And now let's find our second solution. So again, negative 3, so I hit the 3 then the negative button, minus, alright, 53 square root equals, because that 7 number was the square root of 53. Alright, so we've got negative 10 point, oh hot mess. Alright, divide that by 2. So our selection, negative 5.14, okay. Yes, usually they'll tell you what to round to. Alright, So these are my two inputs for the solutions where these, where my linear function, so where b of x intersects a of x. So to find the solution, you can plug into either of these equations to find your y value. Because again, it's the solution, it's what they have in common. So I'm going to use my linear one just because that looks a little bit easier. So negative 6x plus 16. Alright, so I'm plugging in 2.14. And then I'm going to do it again with my negative 5.14. Alright, so get out our handy dandy calculator. And yes, if they're wanting you to do this, they're going to give you a calculator. Let's see. Okay, so 6 negative times 2 and 14/100 equals, and then I'm going to add my 16. So my first y value, 3.16. So 3 and 16/100. And let's do it again. So negative 6 times negative 5 and 14/100 plus 16, 46 and 84/100. Yes, perfect. All right, so these are my x's, these are my y's. So my actual solutions, because they are ordered pairs, so our solutions are 2.14, 3.16, and negative 5.14, negative 5 and 14/100, and 46 and 84/100. So these are our two solutions. Okay? Again, successive approximation, if you're given a table with missing values, what happens is they're going to give you a table and you're going to have to come in and find like to the nearest tenth. You're going to have to do a lot of guessing and checking. Well, if we have the function rules, we can just set them equal to 0 and solve because we know how to solve quadratics. Yes, there's a good chance that they're not going to be pretty, so you are going to have to use quadratic formula to help you solve these. It's okay. We have a calculator. We will persevere. All right, so try these out on your own. See how you do. Let me know if you need any help.